influence of Mars can cause disturbances in Earth's atmosphere, such as auroras and fluctuations in the Earth's magnetic field. Similarly, the gravitational influence of Earth can cause tides on Mars and other subtle effects. Another interesting interaction is the one between Saturn and its moon Enceladus. Enceladus is a small, icy moon that orbits close to Saturn. Its surface is covered in cracks and fissures, which release geysers of water vapor and ice particles into space. These geysers are thought to be caused by the tidal forces of Saturn, which cause the moon's interior to heat up and create a subsurface ocean. This interaction between Saturn and Enceladus is important because it suggests that other icy moons in the solar system, such as Europa and Ganymede, could also have subsurface oceans and potentially support life. In addition to moons, planets can also interact with asteroids and comets. These small bodies can pose a threat to planets if they collide, but they can also be a valuable source of information about the history of the solar system. One example is the asteroid Bennu, which was visited by the OSIRIS-REx spacecraft in 2020. Bennu is a small, rocky asteroid that is thought to be a remnant from the early solar system. Studying Bennu can provide insights into the conditions and processes that were present during the formation of the solar system. Finally, planets can also interact with the Sun itself. The Sun's energy output can vary over time, which can influence the climates and weather patterns of planets. This interaction is known as solar forcing and is believed to have played a role in past climate changes on Earth. Let's continue exploring the interactions between planets and other celestial bodies in the solar system. One interesting example is the interaction between Jupiter and its moons. Jupiter has 79 known moons, 4 of which are known as the Galilean moons: Io, Europa, Ganymede, and Callisto. These moons are of particular interest because they interact with each other and with Jupiter through their gravitational forces. For example, the gravitational pull of Jupiter causes the moons to be tidally locked, meaning they always show the same face to Jupiter. This interaction also causes tidal heating, which generates internal heat within the moons. Io, in particular, experiences intense volcanic activity due to this tidal heating. This interaction between Jupiter and its moons is important because it helps us understand how moons can evolve and potentially support life. Another interesting interaction is the one between the dwarf planet Pluto and its moon Charon. Charon is roughly half the size of Pluto and orbits very close to it. This interaction has caused the two bodies to become tidally locked, meaning they always show the same face to each other. This interaction has also caused Charon to become highly reflective, which suggests that it is covered in water ice. This is significant because it implies that there may be a subsurface ocean on Charon, which could potentially support life. In addition to moons, planets can also interact with comets. Comets are small, icy bodies that orbit the Sun in highly elliptical orbits.